Hello everyone, today we will be comparing Android and iOS security features. The members of our groups are Alberto Martinez, Patricia Secas, Ana Marinas, and Humberto Franier. The two most popular operating systems in the mobile market today are iOS and Android. iOS is the mobile operating system developed by Apple, which is found in their iPhones. Android is the mobile operating system developed by Google. iOS and Android have become primary targets for cyber attacks since mobile devices can hold banking information, social media connections, and online shopping profiles. iOS is known as a closed system, where each application on the phone is closely inspected to reduce malicious content. Android, on the other hand, is an open source which allows users more personal customizations and apps available. Each operating system has their own unique security features, but also contains their own flaws. The purpose of this presentation is to explain the iOS and Android features, review their application security. We will be reviewing the data protection and network security, as well as the privacy and vulnerabilities and exploits. Mobile phones are drastically becoming more sophisticated as technology advances. Each year, mobile companies challenge each other to create innovative new features and applications that will fascinate the minds of their customers. Each mobile operating system is responsible for introducing the world to technologies accessible to mobile phones that were never thought possible. With new designs and features, it is important that companies also recognize how significant it is to keep their devices secure. In today's age, mobile security is important because there is so much personal and business information that can be stored with smartphones. With the growth of ubiquitous devices, it is easier now to share information among mobile devices for ease of use. Vulnerability to security can cause losses in revenue and lose the trust of their faithful customers. Now I will pass it to Patricia to discuss Android and its security features.
Thank you, Alberto. Android background. Android is an open source mobile operating system based on Linux kernel, first developed by a company named Android Inc., thanks to a collaboration with Google then in 2007 through an Open Handset Alliance OHA, giving the Android the opportunity to deliver a complete software set of which includes the OS, middleware, and mobile application. Google used Dalvik, which powered Android with a virtual machine that was designed to optimize battery power and maintain functionality in an environment with limited memory and CPU power, such as that of mobile phone, netbooks, and tablet PCs. The first commercial Android version was released in September 23, 2008, and it was called Android 1.0. Other versions are Android Cupcake, Donut, Gingerbread, Honeycomb, Jelly Bean, Kit Kat, Lollipop, Marshmallow, O or Oreo, Pie, among others. Android is known as the most popular operating system for smartphones nowadays. Let's talk now about system security. The major enhancements to protect your operating systems with Android are: Android now has verified boot mechanism, where every signature of every stage of boot is checked before being run. The rollback protection verifies boot will no longer allow to boot an operating system that is known to have rolled back to an older version. Bootloader unlocking mechanism has been hardened. Only you, the user, will be able to perform unlocking of the bootloader. The OS kernel is developed with SE Linux. SE Linux reduced severity of almost half of kernel bugs. Hardening the user space, it compromises the kernel. The kernel is usually aimed by attackers since it is the heart of the operation. The main reason of the bugs in the kernel happen when copying user data into the kernel. Android has resolved this issue, getting a copy of a feature called hardened user copy from Linux upstream community and the ARM. The module has been loaded along with other features such as pan emulation. Let's continue talking about application security. At the last quarter of 2016, the total number of applications available in Google Play Store was 2.6 million, and a total number of Android operating system-based smartphones sold was 2.1 billion. The market share of Android in the first quarter of 2016 was 84.1%. The rest was spread among iOS, Windows, BlackBerry, and others. Therefore, it is clear that Android has the widest market when compared to other mobile operating systems. In Android, applications can be downloaded from Google Play, but it is also possible to download and install applications from unknown sources. Unknown sources is a technology that can approve a source from where to download the software to be used on the phone. That's the way that Android is protecting the user. Another way is verified applications API. This is another way that is used by Google to protect the applications for the user. Instant apps. Instant apps are a recent application model that Google is adapting. This is about apps that you can use, but they are not installed on your Android device. The way you can access is through a URL, and it opens immediately in an Android application. Since you can go to unknown sources, Android software addresses these by permissions and the use of HTTPS instead of HTTP by default. Google Play Protect is an engine created by Google to protect all the devices in an Android ecosystem. This depicts around 2 billion plus devices around the world, scanning over 50 billion devices and applications every single day. Now let's talk about data protection. Android protects data by using encryption. All Android devices are required to support encryption and to have it enabled by default since Android Marshmallow version. Another way to protect user data is to improve the secure lock screen experience. So for example, in Android Marshmallow, fingerprint sensors were adapted. Then on Android Nougat, PIN pattern password verify was adapted. And last, on Android Oreo, a tamper-resistant hardware was applied. This is like having the chip from the credit cards embedded in the hardware and using it to do PIN pattern password verification. With all these changes, to perform a physical attack on the devices, it's much harder to bypass the lock screen. Now, let's talk about the network security, privacy vulnerabilities, and exploits. There are several security attacks in Android. On the attacks we find, we have the permission escalation attacks, which allows a malicious application to collaborate with other apps to access critical resources without requesting for corresponding permission. Collision attack is a technique where two or more applications share the same user ID so they can have access the permissions which are granted to each other. And last, spyware, which is a type of malware that can be downloaded automatically for a malicious website or from apps downloaded from unknown sources. Another type of malware is ransomware. In the ransomware, this type of malware takes over your device and then demands payment before it lets you back in, and they typically abuse a system alarm window permission to display an overlay on top of your entire screen. This way, you can interact with your device. To address this situation, Google has changed the system alert window permission so the ransomware cannot cover up critical system windows such as lock screen, status bar, and or IME. And now I'm going to have Anna, who is going to talk about iOS and the security features.
Thank you, Patricia. We're going to talk now about iOS, which is Apple's operating system for handheld and smartphone devices since 2007. iOS is the Apple proprietary system for its smartphone and portable devices. To ensure the safety of an Apple device porting iOS is compliant and vetted to only Apple signed software or hardware, Apple implements strict operations on the system that follow a chain trust throughout all the components of all porting iOS devices, from the hardware up to the software level. We will break down the security process that goes toward each component on an iOS device. First is the security boot chain. The boot chain is simply the startup process that a device has when it's being turned on. This step makes sure that an original Apple signed software of iBoot is run so it then can verify and run the iOS kernel. After this step, iOS also uses a method called System Software Authorization. This method makes sure that an iOS system cannot be downgraded to previous versions. This is an important step to prohibit attackers from downgrading a device to exploit all known vulnerabilities. Furthermore, iOS systems contain a security enclave, which is a coprocessor living as a system on chip that has its own separate operating system and takes care of the data protection portion of the device. This includes overseeing the cryptographic procedures so that the data is always protected even if the kernel gets compromised. The security enclave architecture and processes vary by chip on the Apple device. Two other components for the system security are the operating system kernel and system coprocessor integrity production. For method of authentication, Apple uses biometric data such as fingerprint and face recognition throughout the Touch ID and Face ID sensors. An important element that all smartphones must have to increase their productivity and appeal are its apps. However, app security is imperative so that user data and device security is compromised. App, Apple iOS devices use a combination of app code signing, sandboxes, secure platform, runtime process security, app groups, among other processes to ensure user data is not handled improperly and device security standards remain. iOS systems have further security implementations to protect user data on an Apple device. This includes strong cryptographic algorithms and processes to secure data at rest. Apple's white paper, iOS Security, iOS devices deal their hardware encryption throughout an AES 256-bit crypto engine embedded for file encryption. The data protection portion of the iOS system uses the crypto engine to assign a unique key to each file, which is then used to encrypt and decrypt the file on Apple's file system whenever it's called by the user. Apple also uses passcodes to avoid unauthorized access to an iOS system. The passcode is married to the device UID and a large iteration count, where each attempt takes 80 milliseconds. The intentional design is used to slow down each try to discourage and protect against a brute force attack. Apple uses data encryption classes, which have different policy rules on how files can be accessed. These classes include complete protection, protected unless open, protected until first user authentication, and no protection, among others. Next, we're going to talk about the network security, privacy, vulnerabilities, and exploit of iOS devices. Even though Apple has focused on instilling secure standards to their products, there are still some security vulnerabilities that malicious actors try to exploit for their advantages. A couple of known high-level vulnerabilities on Apple's products, as seen in iPhone 6 running iOS 8, include passcode bypass on trusted machines and backup files in local machines that are not encrypted and can be accessible by third-party applications. When it comes to exploits, a study made by Garcia and Rodriguez on the paper A Peek Under the Hood of iOS Malware showed that most Apple malware target jailbroken devices, and only 30.5% of the malware affect non-jailbroken devices. Most malware comes from untrusted applications installed by users or malicious apps in the App Store that were able to bypass Apple's vetted process of code revision. Moreover, only 8.3% of the malware were exploiting iOS vulnerabilities. They classify malware in three categories: on sale, state sponsored, and underground malware. Their study shows Apple does a good job in preventing malicious code to be executed on an iOS device. However, the security measure implemented diminishes exponentially when users jailbreak their devices or when installing and giving too much permission to untrusted or suspicious applications. Now we're going to have Humberto, who's going to compare the security features between Android and iOS devices.
Thank you, Anita. When it comes to similarities, both Android and iOS systems have things in common, like traditional access control, such as password and idle time screen locking to protect the device itself, system isolation, permission-based access control, which grants each application a set of permissions to limit its access to a specific device,
Both have limited hardware access and resistance to web-based attacks. However, when it comes to distribution mechanisms, there are a few differences between Android and iOS. For example, Android offers more opportunities and methods to load applications, while iOS can only be distributed through the Apple App Store. Another differences between Android and iOS is the way they encrypt devices. When it comes to application testing, it will vary between Android markets, while for iOS, it will vary between the different Apple's app stores. When it comes to security and privacy, um, Android apps are not fully tested. Therefore, unauthorized access to sensitive data has already occurred. While for iOS systems, apps can be removed from iTunes Store after badly behavior is detected. Last but not least, when it comes to security features, there are a few differences also between Android and iOS. Android's application manifest contains a static list of permissions requested by the app, while iOS systems, the features are protected and requires user interaction to be installed on the device. Also, iOS offers geolocation when your device is lost, while Android system cannot offer this functionality due to the fact that it requires the user interaction to install the app. Also, iOS system offers the possibility to delete or restore your data on the phone whilst your device has been is lost or recovered. And now I will pass the ball to Alberto to wrap up our presentation.
To conclude, it is important that we recognize all the security features that are found in our mobile devices today to protect all of our data. In this presentation, we provided an overview of the Android and iOS operating system. We reviewed their security features, and we compared and contrasted the different security applications found in these devices. Thank you.